Hey guys, this is Ron. So in this video, we'll talk about EIGRP and route filtering. So as you can see, there's a couple ways to do route filtering in EIGRP. And the whole point of route filtering is we're trying to affect the advertisements that we either allow into our router or send from our router. So they're either applied inbound or outbound. So if I have this shipping partner here on my left, and so they have a connection into my network, I'm going to allow them to interact with the rest of my network. I'm going to make my advertisements via EIGRP, but I want to be somewhat selective on the routes that end up on R5. Okay, so for this first portion, we'll be using a distribute list, but we'll apply it with an access list. And so again, what I'm trying to accomplish here is to affect the routing table on R5. So I want R5 to be able to talk to R3, but I don't want R5 to be able to talk to anything else in my network. So I want to ensure that my shipping partner's LAN out here can talk to the logistics LAN down here. And so again, I apply my distribute lists to affect routing tables, and I'm going to do that either inbound or outbound. So if I were to apply a distribute list inbound to R4, what that would look like is an advertisement for this LAN would come from R3, it would go outbound from R3, inbound to R1, then it would go outbound from R1 and inbound to R4. So again, if I were to apply inbound, it's an advertisement coming from another device into that device that I have the distribute list on. Equally, an advertisement for this LAN will go outbound from R5 and come inbound to R4. So again, I can either accept those, and because those are the only things that I'm accepting, those should be the only things that I make an advertisement out, other than my connected interfaces. Now if I apply it outbound, I'm going to allow everything to come into R4, so I'll have a full routing table on R4, but now I'm selective on what I'll advertise from R4. So that's an advertisement coming from R4 to R5 and from R4 to R1. Okay, so I'm going to apply my distribute list outbound, and I'm going to allow this to be advertised out of R4 so that the rest of my network on this side knows how to get to this LAN. And I'm also going to allow an advertisement for this LAN to be advertised out of R4 so that R5 is at least aware of and knows how to get to this network. All right. Now, because I haven't allowed anything else to go through, R5 shouldn't be aware of this address. It shouldn't be aware of any of these addresses, and it shouldn't be aware of this address. Okay, so let's go ahead and build that. So if I bring up R4 here, I'll do a config T, and I'm going to build an access list. And it's just going to be a standard access list. I'll just give it an access list number of 1. And then I'm going to go ahead and permit 172.16.8.0. So this is my logistics LAN. Now it's a /21. And then I'm going to permit 16. All right. So this was, if I bring this down, this was this LAN and this LAN. Okay. And then I'll put a access list 1 deny any. Now obviously I don't have to put that, but I like to have those written at the end. Now I'm going to apply it to my distribute list. Now the distribute list directly interacts with EIGRP, so you'll find it under router EIGRP. So distribute list, I can specify an IP access list number. So I built access list 1, and then I'm going to apply it outbound. So once applied, EIGRP is going to have to go through a resync process. So it's going to have to basically tear down, in a sense, all the advertisements it made to its neighbors and resync so that it can rebuild their route tables. So if I come to R5, do a show IP route EIGRP, the only network that R5 is aware of is the 172.16.8.0 network. And that is, again, our logistics. If I come to R3, which is my logistics node, it has a fuller routing table because, again, it's on the inside of my network, so it gets more advertisements. And it's aware of this 172.16.16 network. Again, this is our shipping partner. So what I should find is I can ping 172.16.16. This is router 5, and I'm going to source it from my loopback address, which is this logistics network. So from the logistics network, I can hit my shipping partner. But let's see if I can do the same thing on R2. So let's go ahead and copy this. So R2 is my administration, and I can't hit it. Again, this is because my shipping partner only has a route to my 8.0 network. So I'm trying to send a ping from administration. It'll go all the way through the network, hit my shipping partner, but then my shipping partner doesn't know about this address, so it can't get back to it. So it just gets dropped. Because again, the only thing it's aware of is this network. Okay? So that's a distribute list with an access list. Okay? So let's now look at a prefix list. So prefix list allows me to do something very similar to the access list, but it allows me to get a little bit more granular about the prefixes that I allow through. So in this case, we allowed this network and this network to be sent outbound from R4. This time, we're going to allow anything with a /21 to cross R4. So let's go back to R4. I'm going to take that distribute list off. And now this time, I'm going to build a prefix list. So IP prefix list. I can give it a name. So this is going to be only LANs. So this is going to be those /21 networks. And in this case, I'm going to do a permit. And I have to specify a network and a network length, right? So here I'm going to choose initially all of the routes that should match. So I'm going to go a little bit wide with this. So anything that starts with 172.16 will match, okay? So everything, again, in that larger network will get grabbed up. But the second portion of here is I can get now, more granular about the actual prefix that's assigned to that network. So in my case, I'm going to do a greater than or equal to 21. And I can also do a less than or equal to 21. And so what this ends up being is anything that starts with 172.16, but its subnet mask is a /21, or its prefix is a /21, because again, the only thing that will be both greater than or equal to and less than or equal to 21 is a /21. Okay, so then I can do IP prefix list, only LANs, deny. And again, I don't have to do this. I just prefer to have a deny basically anything at the end. Okay? and I can just hit enter there because, again, I'm just trying to block everything. I don't care what the prefix is. So again, if it had a /21 and it was part of the 172.16 network, I'm going to allow it through, so permit. And then everything else will get blocked. So under router EIGRP, I've got a distribute list again. And this time, instead of doing an access list, I'm doing a prefix list. And I've got this thing called only lands. I'm going to apply it outbound as well. So again, what we should see is we have a full routing table in R5, but once the resync happens, I drop down to only knowing about the 2/21s inside the network. So this is my administration, and this is my logistics. And then on the inside of my network, show IP route EIGRP. I'm also aware of the 16 network that is my shipping partner. So again, I should be able to arrow up, ping my shipping partner. If I come up to my logistics or my administration, I can now hit it as well. Again, R5 is aware of these 2/21 networks on the inside of my network. So again, prefix lists do things quite similar to the access list, but allow you to get a little bit more granular. Now the last portion that we're going to talk about is the route map. Now we're only going to scratch the surface of a route map. Route maps are used all over the place. You can use them not only for filtering, but you can use them when you do distribution or redistribution. So that's like a RIP advertisement getting fed into your EIGRP, or your EIGRP getting fed into OSPF, so on and so forth. You can also use it when building BGP. So we'll see it when we talk about that. And then we'll also see it when we do some of the policy-based routing. So we can really start to affect the routing and how we send things across our network by building some policies surrounding how routing takes place in our network. And we do that through route maps and some other things. So again, route maps are very powerful, but this morning all we'll talk about is how to apply that for route filtering. So in this example, let's go ahead and take off our distribute list. And what we're going to try to accomplish this time is we're going to try to block all of these small networks. So we've set up a quad 4s, quad 1s, quad 2s, quad 3s, quad 5s in order to manage our routers, right? Well, those are all /32 loopback addresses. And so we want to block those from being advertised out of R4. So if we come back here, the first thing we're going to do is go back to our trusty prefix list, because prefix lists make it really easy to grab up routes that have specific prefixes. So in our case, we'll do an IP prefix list. We'll call this no loopbacks. This will be a permit, and I'll talk about that here in a second. We'll have quad 0/0. So this is going to match any route. Any single route that comes through here is going to get matched, as long as its prefix list is greater than or equal to 32. Okay? And that's the only line that I'm going to put in that prefix list. So it looks a little bit odd. Again, it's a permit instead of a deny, even though the intent of this overall rule will be to block all of those /32 networks. But instead here we're going to do a permit for all the networks that have, again, a prefix list that is greater than or equal to 32. And you'll see why here in a second. So I'm going to start my route map now. So route map, and I have to give it a name. So I'm going to give it the same name as I gave my prefix list, just to keep it simple. So no loopbacks. And now I can specify a sequence number. So I'll give it a sequence number of 10. Actually, let's do first we'll do a deny and then specify our sequence number. Now, if you don't specify permit or deny, it's going to default to permit. So in my case, again, I'm trying to block these routes from being distributed from R4. So I'm going to do deny, and then I just specify my sequence number because it makes it easier to modify the route map later on. Okay, so now notice that the prompt changed to config route map. So now we're inside of our route map. And I have a couple different options here. The one I'm going to focus on is the match. So with every rule that you add to your route map, you typically have a match statement. So this is how, what mechanisms or networks or whatever am I going to apply this rule to? And that's what the match statement is for. So I'm going to match, and notice there's a lot of different things that we can begin matching on, and that's because the route map is used in quite a few different places. But I'm just going to match IP address. I'm going to apply my prefix list of no loopbacks. And then I'm just going to go ahead and hit enter. So if I do show route map, I have a single rule so far. So I have my route map called no loopbacks. It has a single deny statement in it. Under that deny statement, it has a match clause. And the things that are going to be matched is this prefix list called no loopbacks. So my no loopbacks prefix list had a single permit statement. And that was so that what gets forwarded up to this match statement are those routes that have the /32 subnet mask, right? So if I had denied them in the prefix list, they would never be forwarded up to this match clause, which means they would never be denied by my route map. So you have to really be careful about how you lay these things out. Again, I want to permit it on my prefix list here so that it gets forwarded up to this match clause so that I can apply this deny to it. Okay? Now, so far I've only specified a deny, and just like our access lists, there's an implicit deny at the end. So now I need to add a permit to allow all the rest of my routes to make it through. So the way that I'm going to do that, I can do route map. Well, I can exit out so that I can use the question mark again. Route map. I'm going to give it a name. And this is that no loopbacks. This is going to be a permit. And now I can specify a sequence number. So I'm going to specify sequence number 20. And now I'm right back inside of that rule, just like I was in the deny 10. Now instead of specifying a match criteria, I'm just going to leave it alone. I'm just going to exit right back out. Now if I do a do show route map, I now have two entries. I have our deny that matches those loopbacks, but I also have a permit that has no match clause. And if it has no match clause, it will match everything. Okay? So I'm going to leave that as is. So the route map is now complete. So now I have to apply it to my distribute list. So router EIGRP1 distribute list I'm going to specify a route map. And the route map that I've named no loopbacks. Oops. And I have to apply it outbound. So now what I should see after the resync, if I come to R5, before the resync, I have all of these quad 1s, quad 2s, quad 3s, quad 4s. Now that the resync has taken place, now I no longer have those networks, right? So I still have my 192s that are going between my routers, and I have the LANs hanging off of those routers, but I no longer have these /32 networks. Okay? So that was the route map. Okay? So we built our distribute list using either an access list, prefix list, or route map. And the whole intent behind the distribute list was to affect the way that R4 participated in routing. So we applied all of our stuff outbound from R4. So that would be from R4 to R5 or from R4 to R1. But we could have also applied them inbound. It really just depends on what you're trying to accomplish. So I don't control R5 because that's my shipping partner's router. So it was easy enough for me to apply my stuff outbound so that I'm affecting the things that I advertise to my shipping partner. So I hope you found this helpful. Route maps are pretty cool. Like I said, we're going to see those in multiple places. Prefix lists allow you to get real granular on selecting some of those routes. And access lists, well, they're access lists. We use them all over the place. So thanks for watching.